There are times when we will see what we refer to as a complex road subgrade. In this example, what we have is oftentimes a road that will be graded one season for top of dirt, and then the next season other crews will come in and place the base and aggregate and paving courses to finish up the job. What we want to look at is how this differs from the standard road subgrade that we previously reviewed. Initially, we have a road that slopes at 2% from what we consider the grade point, the profile grade line, PGL. This is more likely than not the point of vertical orientation and rotation of the job. Sometimes you'll see divided highways like this having a center line that runs down the median, but the horizontal information is provided at this profile grade point here. It doesn't really matter, it's just your baseline where things break. This is an apex of where things break to the left and break to the right as far as you're concerned. So you're going to horizontally locate the vertical in this point and go from there. We start out with a 2% slope here to the left. We break to a 4% shoulder, and then we have a foreslope that's going to vary according to what the conditions are. And those are oftentimes outlined in side tables or by standard details provided by the state. When we get to the other side of the shoulder, you'll see we have the same 4% shoulder and a foreslope. But here's the interesting thing. If we look, the subgrade follows 2% the entire way across. Now it does break here at the PGL, so it's a minus 2% here and it's a minus 2% here. So this is the basics for a complex road subgrade in a tangent section. If we're going to calculate the subgrade hinge, we can possibly do it in a tangent section because we do have some consistency. So here's how the process goes. We come out to the profile grade point and we drop that the distance of all the layers down to subgrade. So what we've done now is we've basically taken the profile and moved it from here down to here. At that point, in your software, you're going to build a template that projects a negative 2% in this direction and a negative 2% in this direction. The thing is, you need to have your finished surface built because these foreslopes need to be in so the software will project the subgrade out to that all-important subgrade hinge. You need to calculate it by using the software, but there are times in tangent sections where you can come down like we did in a simple subgrade and calculate this and give yourself a horizontal offset in a tangent section for a subgrade. If you have a road that has a complex subgrade, it's just Murphy's Law that you're going to have super elevated curves, and that kind of throws the idea of one typical section, no supers, easy road. I can calculate a horizontal offset for that subgrade hinge. What we see here is calculations for the subgrade in super elevated conditions. Now, there's two things that are important to note that happen in a super elevation. The first one is the rotation of the driving lanes, which are over here, and if you remember, this is actually the shoulder and not a driving lane. Now, in this situation, we show this road in full super, and what occurs is at some point these two catch up to each other and then start rotating at the same slope. There is also calculations provided by the state. It's usually an algebraic breakover that allows the front slope, the force slope here, to not exceed a certain percentage difference from the super elevated slope. These are often outlined in tables off to the side on the details pages, or they're just part of the state standard details. So you've got to pay particular attention when building the finish road, and then once that is done, now it's time to do the subgrade. Again, another model has to be produced and another set of calculations has to be run. Here I am drawing our PGL, but look at what happens off to the right. We have our same negative 2% out to the subgrade hinge, but on the left, this is going to change and roll up and roll out at the same rate as the super elevation. So what you've got to do is make sure that this stays parallel to the super elevation on this side and then follows 2% here. Again, it's complex modeling, but once you get the finished surface done, these subgrade calculations will actually become a lot easier.